Okay, thank you everyone for joining our webinar, Choosing the Right Storage Platform for Your Offsite Backup and Disaster Recovery. My name is Gerard Heiner. I'm the Chief Business Officer here at Webair. Been with the company for approximately 15 years. I am joined today by my colleague and Webair CTO, Siggy Brody. Siggy's going to be presenting the webinar now.
Hello, thanks, Gerard. As Gerard mentioned, my name is Siggy Brody. I'm the CTO of Webair. Webair is a managed cloud service provider. We've been in business for over 20 years now, and we have a focus on providing managed infrastructure for production workloads in the public and private clouds, offsite disaster recovery and backups, managed networking, hybrid IT, and pretty much everything in the middle. We do operate internationally. We have infrastructure deployed in all these regions. And we do have a focus on disaster recovery and offsite backups, which is what we're talking about today. And some of the industry analysts have been nice enough to graciously mention us in these reports here. We talk about our services. We do have a focus on security and compliance. And you can see some of our certifications listed here as well. And this is specifically important for offsite backups and DR because if you're storing your critical private data somewhere that's not within your physical premises, you want to be sure that it is properly protected. So some of the things we'll be talking about today relates to how to secure your data locally and offsite. So today we'll be talking about the proper targets for your local backups as well as offsite backups and where to replicate to for disaster recovery. So this is really a technology conversation, but we'll see how we sort of go into other areas when discussing these options. And so we'll be looking at production storage arrays that will be at your premises, secondary arrays or appliances specifically designed for these use cases, the public cloud, obviously, managed providers like Webair, and targets specifically designed for archival storage. And then we'll also look at what does it look like if you were to build that at another physical location versus consume a service or a public cloud. So just the first thing that we should really make clear here is it's really two separate conversations. It's not one platform to rule them all. Backups is not the same as offsite disaster recovery. They are two separate use cases. They require separate strategies, sometimes separate teams. And can you mix and match them at times? Yes, but it's very specific depending on your use case. One example is, let's say you only have a short-term offsite backup retention. Maybe you only want to keep offsite backups for a few days. And you're also looking for disaster recovery. Well, certainly you can use your disaster recovery journal to recover data back to your production. If you have a long-term archival data retention policy, maybe a legal hold, you have to keep copies of all your data going back 7 years, and you want to recover from ransomware, you really are looking at two separate conversations. So we do look at them as separate, and it is dangerous when you talk to a vendor or provider who kind of glosses over this fact and says, here's a solution for offsite backups and disaster recovery. You have to really dive deep, which is what we'll be doing today. So why is any of this important? Well, we don't want people to have a false sense of security thinking that they are protected. They could recover from ransomware that might have been in their system for months, or human error or natural disasters, because obviously that would result in downtime and lost business revenue. And some of the examples of how to think about something like this is maybe you do have a disaster recovery strategy, but maybe you haven't tested it lately. Maybe it can't handle your production workloads. Maybe you spun up test VMs and your applications function, but maybe they don't function under load. Or maybe you have tested it under load and it works fine, but have you actually tested that it can operate under your typical load and still have enough capacity to replicate in reverse back to your production infrastructure when it becomes available again? If not, you might never be able to recover back without actually taking down DR and going through a very long and manual and offline failback procedure. or maybe you're using a public cloud or some sort of capability where you can store data inexpensively and then quote unquote spin up as needed. That's fine, but do you actually know what infrastructure and at what cost you will need to use during that spin up event? If you don't and it hasn't been mapped out, then you might be sort of making game day changes and throwing more resources at it, spending a lot of money, and ultimately really increasing the RTO for your recovery. The same thing goes for backups. You certainly might have a backup platform that can ingest your backups without an issue, but can it support your normal backup ingestion and at the same time handle multiple restores back? Or maybe you can, but maybe that's gonna cause your backups to spill into business hours. These are the types of things that you really need to care about when you design the systems. Maybe your backups work fine, but when you lose one or two disks, when your RAID has to rebuild, again, it's under such a load that it can never recover. So we want to be sure that we dive deep and we don't have those false sense of security there. So when you think of local backup targets, local storage infrastructure at the customer premises, there are a lot of options there. And we're not here from the lens of a vendor trying to sell you storage or trying to sell you software for your premises. We're a cloud service provider, and so the only sort of vantage point that we have is when our customers call us and say, hey, our offsite backups aren't working, or our copies to Webair aren't working. We troubleshoot them, we investigate, and sort of surprisingly or unsurprisingly, most of those issues are actually related to problems at the local infrastructure or local backup storage targets that have not been sized correctly. So to take a step back, the first thing to really consider is what is your actual policy or requirements for local backups? Do you even need local backups, or do you're more than comfortable to send all your backups offsite or to the cloud? A lot of times people sort of jump into this without having those policies mapped out. If you're not sure what your standards are, there's certainly plenty of sort of industry best practices, depending on the industry that you're in, that you can kind of gravitate towards or use. So when considering the different targets for local backups, obviously you can look at secondary storage arrays, software-defined storage where you deploy commercial software on legacy hardware, network-attached storage, filers, or even production storage. So production storage is obviously not the ideal place for your backups because that's what you're backing up on there. But maybe you are comfortable for whatever reason of only having offsite backups, and maybe you just need a sort of a place to store those local backups before they get shipped offsite. So in that sense, production, if you have enough spare production storage, that would actually facilitate that requirement. And if it's a dedupe appliance, then you're actually not going to be wasting any actual space when you take those local backups, and they'll finish super fast. Regardless of what you're looking at for your local backup target, there's a few things to consider that we've seen as sort of typical pitfalls or gotchas from our customers. One is if you are running a virtualized backup server or even a physical backup server, don't consume the actual storage appliance or storage platform as local storage. Just if you're running a backup server as a VM, don't attach NAS or block storage as a VMDK. That's a recipe for a disaster because obviously those things can grow very large. If you try snapshotting it, you're going to run into a lot of trouble. Instead, segment your storage plane from your control plane. Attach the storage via NFS directly into the VM, or via block storage, maybe via iSCSI directly into the VM. The beauty there is if that server ever gets corrupt, you run into trouble, or you need to reinstall it, you don't have to touch the storage at all. You install a new server, attach it to your storage, scan, and all your data is still there. And so just think of typical data plane from control plane separation applied to a backup server. We've also seen a lot of trouble when people try to mix and match dedupe appliances with other storage platforms. They typically don't work too well together. And if you are using NAS, NFS, or CIFS via a shared storage infrastructure like a NetApp filer or like a QNAP or whatever, if you're using a scale-out system that has multiple nodes that allows you to make multiple concurrent connections, be sure that you can actually utilize concurrent connections to your storage platform. If you're using one global namespace that you provide to your backup infrastructure, all of the backups are going to be funneled through that one connection, which is probably just hitting one node. I'll show you an example in a minute of a better way to architect that. The other thing is if you're being sold a scale-out system, maybe like a dedupe appliance where you can just keep adding more appliances to, and they say it's a grid or it's a cluster that can scale out. Be sure you really drill down and understand what that means. Does it mean that you can lose a node and there's been no loss of data at all, and you can still ingest more backups, or are they just referring to the fact that maybe they have a global dedupe domain? And it's not an actual resilient or scaled out platform. And we see this a lot, so you have to understand, what does that actually mean? Yes, George.
So as a chief business officer here at Webair, over the years, I've had prospects and clients as things are basically say things, oh, I have disaster recovery as a service, I don't need backups, or I have backups, I don't need DR. But to be truly protected and have business continuity, you really do need both.
You do need both. I mean, backups and DR are essentially designed for two different use cases. Backups are designed to recover data from a day ago or 10 years ago. Disaster recovery is designed to make your applications available in light of some sort of outage or attack. So yeah, there's different strategies around both of them for sure. And that's why it's important too, even locally, to the local backup serves a purpose. It's your fastest way to recover data. It's not going to make your application available if your infrastructure is down, but for a quick recovery, there's nothing faster than the local backup targets. And that's why, even though we're a cloud company, we always advocate that become part of your solution. And really, what it comes down to is, regardless of what local backup target you're using, what you really want to focus on is something that is going to be scale out, that you can just keep throwing more infrastructure at it and not have to deal with separate backup servers or separate storage appliances that you have to manage individually. You want something that you can just keep adding nodes to. At the same time, something that's going to provide you with resiliency. So if you lose a node, you've not lost any data or any availability. You can still read and write data from the cluster. And ultimately, something that provides you with those two factors and still affords you the ability to have data reduction. So can a scaled out dedupe appliance do this? Sure, but you shouldn't have to go with a vendor specific architecture, a closed dedupe architecture to get data reduction. So if you can find something that provides data reduction, resiliency, and scale out, you really have a flexible local backup architecture. And I'll show you what that looks like in a minute. So before I mentioned that if you're using a NAS as a backup target with a global namespace, on the left here you have what you would typically do. Typically provide the global namespace to your backup server and let it write data, and that's fine. But at some point you're going to hit a roadblock on performance. And what you're going to realize is that even though you might have multiple nodes in your storage cluster, all your backups are just being ingested by one node. Yes, the data is being striped across the back end, but from a network throughput and CPU and memory, it's hitting one node. So what we found is, if you have a scale-out system like let's say an EMC Isilon, create multiple directories and put multiple file proxies in front of each directory and have your backup stripe across them. And so now you'll get that benefit of the scale-up backup, the scale storage architecture, and still be able to utilize the concurrency of all of the CPU memory of that cluster. I also talked a minute ago about trying to find that sort of golden sort of infrastructure where you can get data reduction, resiliency, and something that's scale out. So what we've actually deployed at our sites for that type of architecture is what you're seeing here on the screen. We ended up using Ceph, which is an open source platform, which is highly active from an open source contribution perspective, but it's also commercially supported. So you have companies like IBM Red Hat or SUSE who is providing 24/7 commercial support. So we run that on the back end. It allows us to get resilience. So we actually run erasure coded clusters that allow us to keep 3 copies of every object. So we can lose 3 disks or 2 nodes in a disk, and there's no loss of service, no loss of data. But at the same time, we still can use 66% of those clusters. It's scale out. We can keep throwing hardware at it. And we can actually do even better on the data reduction by presenting it to virtual repositories that are running REFS, which allows us to make use of block cloning. And so this really hits all 3 of those touch points. It's scale out, It's completely resilient, 3 copies. We can even go even deeper if we wanted to. And we get as much data reduction as any dedupe appliance that's out there. And we're not tied to any specific vendor. We can switch to hardware whenever we want. We can switch who's doing our commercial Ceph support. And this is what we've come up with. It might be a little overkill for some smaller sites, but at least it's the right sort of mindset that you want to have. So moving on to offsite backups, there's certainly many platforms to consider. You know, the big one where people are always talking about is public clouds, AWS S3 or Glacier or Azure Blob or something like Backblaze or a managed cloud service provider like Webair. So that, you know, there's no one best platform. I couldn't tell you that this is better than that. It's all based on your use case and your requirements. But again, what are the pitfalls to think about? Well, cost is a big factor here, and this is, you know, there's certainly devils in the details. Some vendors like a Webair, we only charge based on storage. No matter how many times you perform restores or send data or hit it with operations, you'll only be charged on a storage metric. With public clouds, there's obviously other metrics involved, like the cost to restore. If you're storing 100 terabytes on S3 and you want to move that somewhere else and take it offline, you're going to spend almost $10,000 to pull that data back. But I mean, there is a benefit to those platforms. They're very inexpensive, especially something like Glacier. Keep in mind, though, Glacier is not S3. It's not always available. It's not compatible. It's not an S3 compatible store. You have to wait for retrieval. So keep that in mind. People also tend to assume that just because they're sending their data, let's say, to the cloud, let's say like you are using S3, that your data is protected at multiple locations, which is not true. If you want to store your data in different geographical regions, you have to pay for 2 copies of that data. So keep that in mind as well. You also have to consider management. You know, who's accountable to ensure that you configured, let's say, your S3 bucket properly? You know, who's on the hook for that? Well, I mean, you know, the S3 buckets being publicly accessible and having large data exposure is happening all the time in the news. And so think about, do you want a platform where you are responsible to manage, monitor, secure, and scale it, or would you rather have a platform where someone else is in charge of all that? So the nice thing is you don't really have to pick one or the other. You can kind of have the best of both worlds, and this is a model that we advocate. In this model, you would be backing up to an offsite target, which is at a cloud service provider like Webair, which is going to provide you with a target that's not too far away from you. It's in your region. And why is that important? You would think backups, you want it far away. Well, for restores, you want it close. You want to ensure that you can restore data back as quickly as possible. You might also have sovereignty requirements. You might also say that your data can't leave a certain country or a certain state. And so having a target that's not terribly far away in the metro is going to give you that edge compute component. You're going to be able to send your backups offsite super fast and recover them super fast. I'll talk about the management aspects in a minute. But you know, with that cloud service provider model, you're getting that fast recovery, fast restores, but cloud service provider or CSP provider storage tends to be a little bit more expensive. What if you want that cheap and deep archival storage? Well, then what you do is you tier it on the back end. You have the CSP provide you with an archive tier on the back end, which is very far away. So now a few things are going to happen then. Now you have copies of your data in two separate geographies. The other thing, too, is maybe you don't need to keep as much backups locally because you have that in-region fast restore capability. And lastly, you'll get the benefit of cheap public cloud Glacier-like storage costs. So this is this tiered or hybrid approach that we advocate. This is actually what we configure for our customers. They get that best of both worlds. They don't have to pick one or the other. The nice thing about this model, too, is it's fully managed. The CSP, Webair, in our case, provides all the software to run the backups locally. So we actually typically provide Veeam as one of the software components. So we provide the software as part of the solution. We help our customers configure the software locally, configure the local backup jobs properly. We monitor all the backups. So if your copy job to us fails in the middle of the night, we know about it. We open tickets. We help resolve it. It's a vendor neutral service. We're not tied to any software or any hardware vendors. So if you want to go and switch your hardware on site, or switch to a different piece of software, we're fine with that. We're just a delivery vehicle. And at the same time, we will copy your data to an offsite archival tier, which is going to be that cheap and deep. And so you get all these great benefits. Your data is now in multiple locations that are having to pay for 2 copies. You have fast restore capability. You have a partner that's taking ownership and accountability for everything, and you still get to benefit from this cheap and deep storage that everyone else is talking about. So this is really the mature model that the industry has come up with for mid-market enterprise for compliance use cases where you want to encrypt your own data. And this is what our service happens to be like. We're actually ingesting backups for VMware, Hyper-V, physical boxes running Linux or Windows, even IBM platforms, as well as SaaS, Office 365, SharePoint, and OneDrive. And again, you get that full ownership and accountability. You only have to pay for storage. As well as a software license per VM. And so it's a predictable cost model. You're not going to get a surprise bill based on operations, or if you do a big restore, you're not going to be hit with a big bill. It's completely predictable, and we can actually provide you with costing models to show you what you'll be spending over time if you plan on increasing your data set and retaining for long periods.
So pricing predictability seems like it can be a difficult task when utilizing a public cloud scenario.
It for sure it is. Because there are so many metrics, and it's those platforms are designed to run at scale, and they're obviously very sort of low margin type of services that are do it yourself. And if those public clouds don't charge for every single bit and byte, then they're not going to be able to operate. And so there's so many different metrics. Each one's different. But you are completely responsible to be in charge of all that. Now, the other thing too is depending on what software you use, depending on what backup software you use, you might have backup software that's scanning against your public cloud storage every few hours to see what's changed. That might result in operation fees that you don't expect. And so now who's responsible for that? Maybe you didn't ask the right questions when you bought the software, but ultimately it's on you. It's like you're walking into Home Depot and you're buying all the pieces, but you got to take them home and put them all together, opposed to a managed solution where the CSP is giving you a simple cost model. It's how much you're storing, and nothing else really comes into the equation. Thank you for the question. So this is what our service looks like. There's a portal you can actually manage and see all the metrics by which you build. You can chat with someone 24/7 from our portal. There's a 15-minute response time. It's available globally as well. And now let's speak about targets for disaster recovery. And the first thing really to look at is that, we're talking about technical platforms here, but disaster recovery is not a technical platform. It's sort of a way of thinking that has to become part of the way that you think about the business. It's really a resiliency conversation, and it's not just about your IT infrastructure, but it's business resilience. It's how many people do you have? What if someone goes on vacation and they're unable to operate the system? It's about getting out of IT heroics where people spend all weekend getting the system back up and running and they're heroes Monday morning. That's great, but it's really training management the wrong way. Resilience has to be part of the conversation that you have as far as where do you place your production workloads and how. DR cannot be an afterthought that gets bolted on. And let's be clear, we're not talking about I can spin up my backups in the cloud and access them via VPN. That's not disaster recovery. True disaster recovery is not just having that box that you can check. It's really more about not only just copying data, but how can you actually consume your applications at DR as you did in production? You need that capability that's going to hit all of these touch points. It's not about rehydrating backups or having to call your vendor and ask them to provide you with more CPU or memory on demand or copy you a storage platform. It's that hit a button and it just works type of functionality. That's true DR. In regards to storage, you have to replicate many platforms. If you run a complex production architecture, like many of our customers do, if you're mid-market enterprise, or maybe you're a hospital or bank, you're not just going to have everything running on VMware or Hyper-V. You're going to have physical boxes maybe in the environment. You're going to have legacy platforms, stuff that you can't sunset for 2 years, to probably direct into VM mounts with iSCSI or NFS, there is no platform to win them all. If you're running VDI, you have to consider that as well too. And so we're not just talking about storage platforms here. But those are the things to consider. As far as options that you have for different disaster recovery targets, you can certainly just build another facility or repurpose some hardware and replicate yourself. If you have your own equipment, you can maybe you have a backup appliance on premise already that's taking your local backups and providing you with some sort of spin up your environment in the cloud. Those are certainly popular, especially with SMB. Maybe you're replicating to a public cloud vendor, AWS or Azure, or maybe you're replicating to a cloud service provider or a CSP like Webair. So those are the options that we'll consider. So let's attack the local backup appliance first. And this is an area that these, and by the way, these all have their place. These all make sense for a specific customer or user depending on their needs and requirements. So looking at the backup appliances like a Datto appliance, or maybe a Rubrik appliance that gives you a spin-up capability. I like to think of these of boot and browse. Yeah, you can boot up your backups as VMs on the local appliance, and you can browse around, but don't expect to be able to run your applications on that local appliance at production. Unless you have tiny VMs or a very small environment, it's just not going to work if you have any sort of cluster at scale. The same thing with their cloud component. Don't expect to be able to run your entire environment on the cloud they provide you. Oftentimes, those are extremely limited in the amount of CPU and memory resources that you get. Getting them to increase those resources can be very time consuming, and fail back to production is a completely manual and offline process. And that's not even getting into the networking integration component. So backup platforms, you're backing up locally and you can hit a button and spin up the VMs, instant VM recovery, or spin them up in a cloud. Think of them as boot and browse. And if using one of them, I would encourage you to go back to your vendor and say, what am I actually getting? What is the performance? How do I get the same performance that I need from what my production environment requires? And what does failback look like? What does the SLA to get more performance? And how do I integrate with my network so it's seamless to the user? If you're looking at maybe building a second site that you manage and that you're accountable for, that's fine too. What I would caution here is that many customers and organizations look to repurpose older hardware for the DR site. They're like, if they're replacing their production SAN, they're going to take the old one and put it at their DR site. Well, that's something that's certainly an option, but consider a few things there. The array that you place at the DR site might provide you with the same storage that you need, but not with the same performance. And you might say, no, it's fine. I've tested it. I failed over. But just like we mentioned before, not only do you have to consider can it handle production workloads, but can it handle production workloads plus the overhead of replicating back to production? If not, you'll never be able to fail back without a long option. And so that's dangerous because how do you add monitoring performance as part of your change control? The only real way to do it is to have the same exact array at production and DR. So I'll pause here. Gerard, do you have any questions on the?
You had mentioned previously that local backup infrastructure typically fails first. How can a cloud service provider help in those scenarios if they're only providing the cloud component?
Well, they are typically copying your backups to a cloud, or most in Datto's case to their own cloud, and then you would need to call them and rely on them to go through a manual process of spinning up your VMs and relying upon the method that they provide you to access them, typically a VPN. So it really is just a service. If you need to represent that you have a spin up in the cloud or offsite spin up capability, that you're just checking a box. You can never really fail over applications to them in a way that's not going to be extremely time consuming and costly. So there is one scenario that I would like to point out because we've helped some of our customers with it, where if you are building a second site, and you do have an offsite backup and disaster recovery requirement, where you can actually gain some economies of scale if you're running a dedupe array at the DR site. I would only advocate for this scenario if you are totally comfortable running it yourself and the secondary array at DR matches production. But if it happens to be a dedupe array, send your backups data to that array, because if your DR is there as well, your DR data is essentially free from the dedupe. Land it there and then tiered object storage on the back end. So this is a nice reference architecture if you are building a secondary site and you want to save some cost on storage. So let's look at using public cloud as a disaster recovery target. Again, it's totally a feasible option, but there are some considerations. And the devil's in the detail here. The one is that you really need to do your homework on the public cloud target, because they're very rigid, obviously, because they're at scale, and there are sort of many considerations to take into account that would sort of make it appropriate or not. And so here on the screen we have some of the limitations of Microsoft Azure, and we see here that like only virtual machines that Azure supports can be replicated. That seems pretty straightforward. But if you have an older OS, you can't replicate it to them. You can only protect machines that have disks smaller than 4 terabytes. If you want to protect a machine that needs to be accessible via other subnets, which is pretty typical, that machine needs to have at least 2 CPUs and 4 gigs. And maybe you have a lot of smaller VMs, so all of a sudden you have to throw more resources at them for no reason. The number of supported disks and NICs is based on the instance size. So all of a sudden, if you have 3 disks or 3 NICs, now you got to upgrade to a larger virtual machine. And so all of these things can really throw your costing model out of whack, and they need to be considered day one. And there's many other considerations here too, only 20,000 IOPS per zone. So really do your homework on these platforms. The thing too is that these public clouds really don't make any representations that they're properly protecting your data. If you're using their platform and they have some sort of outage or downtime and the data is lost, they are not on the hook. And here's AWS's SLA. If the data was important to you, then you need to protect it. And if you're using their platform as the protection for your data, then be aware that there is no credit that will be provided to you. So let's just look at some of the pros and cons to sort of sum it up here. It's certainly inexpensive. If you're copying your offsite data, let's say to S3, on a monthly basis, it's going to be cheap. They're also widely supported by many software vendors like your Veeams and your Zertos and all that. They give you some sort of DR capability with very little effort, and they're also low commit. But on the opposite side, this is completely self-managed, do it yourself. If you didn't configure the DR right, and there was a security breach, it's on you. If it didn't spin up properly, it's on you. If it got too expensive, it's on you. Also, you can't target all of your platforms here. If you have, as we mentioned before, direct NAS or NFS mounts into VMs or iSCSI, they're not going to support that. We do disaster recovery for many customers where we actually support direct nimble to nimble replication, or 3-port to 3-port, Isilon to Isilon, because those software data movers are not appropriate for every scenario. The same thing goes for networking. If you need to place a physical MPLS circuit in front of your public cloud DR, that's very challenging. If you're using an MSSP that needs a physical tap port to monitor your security, you can't do that always in the public cloud. So the more complex your network, the less feasible these options are for you. If you're doing cross-hypervisor replication too, you need to be sure that the platforms will support your OSs and everything boots up properly. And lastly, the costing model can be very complex as well here. So with the costing model, we talked about it before, but it gets even more complex when looking at disaster recovery, because now you need to track what size instance is appropriate for every VM on your side or server, and you need to track that over time. And as you use more resources at production, now you have to update what does it look like to spin up, and how much does that cost? And that changes over time. So now let's look at a cloud service provider.
Excuse me. It seems from your pros and cons list on the previous slide, obviously people focus on the RTO and RPO and the cost structure, but it really seems like the networking and failback, functionality is equally important and something that you should be aware of.
For sure, the failback can be very expensive, very costly. In the case of public cloud, I'm not aware of any scenario where you can do a seamless failback without going offline and suffering an extended outage on the failback. So on the flip side, but you know, let's just be clear. Like, you know, I'm not really here to say don't use public cloud. If all of your requirements fall within the constraints that I mentioned, if your RTOs and RPOs are not super low, they're not, you know, if they're days, and you're comfortable, you know, being accountable and managing it yourself and being controlled, then it's totally appropriate, and there's tons of people using it. Or if you're a very large organization, on the flip side, again, is fine being accountable for it, and again, falls within the stipulations I mentioned, it's fine too. However, what I found is the larger the organizations, the more edge cases, the more platforms, and more so do they need something that's really customized and tuned to their environment. And I think that's really where the CSP comes in. So with a cloud service provider solution like Webair, what you're going to get is something that's fully managed. You're not buying storage, you're not buying megabits per second or CPU gigahertz. You're contracted towards an SLA that says you're going to be given a 1 hour or 15-minute RPO and maybe a 1 hour RTO, and that's what you hold the CSP accountable to. In the case of Webair, our cost model is really simple. We just charge you based on the number of servers that you're replicating and the amount of storage they're consuming. We provide you with unlimited CPU and memory resources within that model. And so as you increase your infrastructure requirements on premises, you don't even have to tell us. We're going to build our clusters and track that so that if you fail over and you need 30 gigahertz to 300 gigahertz, there's no additional cost. You have that predictable cost model, and it's super simple. We also will own the failover process and the failback process. You can do it yourself from the portal. It's DIY, but you can call us and say, hey, we had an outage and we need to fail over. Because we're placing our customers on like-to-like infrastructure, let's say VMware to VMware, or Hyper-V to Hyper-V, you don't have to worry about all those stipulations like you might have with the public cloud. If it was supported on your production environment, it's going to be supported at DR. You can also co-locate your own physical equipment side by side if you want physical routers or switches in front of your disaster recovery. That can be done. You can mix and match and make it hybrid. So there's truly a lot of options here. And again, you're not going to run into an edge case where the network might not be supported. We typically support all the SD-WAN vendors and MPLS, and there's really nothing we can't support since we're going to provide you with vendor native replication if it comes up. If it comes up that replicating VNX to VNX is better for your scenario than a data mover, which we provide, we'll go that route. On the flip side, you are contracting to maybe a multi-year contract, but that's because there's obviously so much work involved and it's completely customized and tuned to your specific environment. You'll have less exposure to the infrastructure in this scenario than if you built your own secondary site, but it'll be more than what you get in the public cloud. And this really works best if you have a true DR requirement. If you get hit with ransomware and you want your applications to come up and look like as they looked seconds before you got hit, this is really the solution for you. If you have a complex environment, if you have IBM I-Series or P-Series, multiple storage platforms, you need a customized solution like this. That's where it works well. The other thing to consider is the definition of a production infrastructure for enterprise is going hybrid. No one's saying it's all going public cloud for production in the future, or all on-prem, or all hosted private cloud. 80% of CIOs say the definition of their production environment is going to be hybrid in the future. So the CSP model, where we can mix and match your own co-located equipment, private connectivity, SD-WAN, connectivity to public clouds, integration of public clouds where they make sense, that's what you have to look at for DR. To the extent that production's going hybrid, DR has to match it as well. And again, that's never going to be all owned equipment. It's never going to be all public cloud. The CSP, the Webairs of the world, are really the only ones that kind of sit there in the middle and can kind of support everything. And this is even a model that AWS and Azure are perpetuating by releasing Azure Stack and Outpost. So here's an example of what I'm talking about. This is a disaster recovery implementation that we did for one of the top 100 law firms in the world. And yes, we're replicating VMs, and those VMs are consuming storage. But because they're a large organization, we did have to hit a lot of those other touch points, supporting their MPLS network, co-locating network equipment, placing their filers at the DR site, compliance requirements, always-on replication for SQL clustering and Exchange DAGs, and supporting zero RTOs for certain platforms. So again, the larger the organization, the more complex the requirements are. And so really what you have to ask yourself is who do you want to be responsible for all this? Who's taking ownership of data sovereignty and encryption and compliance? And who's on the legal hook for breach? Who's authoring the runbooks? Who's owning failover, failback, change control? And that's where a CSP that's running full management really has value, because if you don't want to be responsible for all those headaches and on the hook and dealing with compliance officers, that's when a CSP really has value. So
it's not just about the technical components. We should be considering people and skills. How does one decide what platforms are best for them when they're looking at it from a business and accountability perspective?
Yeah. I mean, I'm a CTO. I'm throwing megabits and bits and bytes at you, but this is really just as much a people conversation as it is a technical conversation. Do you want to keep your technicians trained up on all this replication technology, and who's doing the testing? In the case of Webair service, which I have up here, and we actually provide managed quarterly testing. Once a quarter, we'll actually work with the application owners of the organization, not just the IT folks. The application owners are the ones who should be doing the testing. They're the ones who can smell out a problem with the app because they're the ones using it every day. And so if you look at the service offering here, we actually give our customers 3 days out of every month to use the replica for free. If you have a copy of your most critical applications, use it for your QA, your patching, run your security scans against it. We'll provide an SLA for an RPO of up to 15 minutes, an RTO of up to 1 hour. And again, there's no declaration fees. There's no cost to use the infrastructure for the first 3 days. And you call us with a problem, you're never going to get hit with an hourly fee. It's all on us. So to kind of sum it up, I think the big takeaway is to kind of go back and map your organization's resiliency. Where do you have pockets in tribal knowledge, or maybe there's only one person who knows how this stuff works today? What are your single points of failure? Which applications are most important to you? This does not have to be an all or nothing conversation. Maybe you have a backup appliance today and you have that cloud spin-up capability, and that might be appropriate for 80% of your applications. But maybe you need something better, a true disaster recovery capability for those other 20%. So map the applications to their requirements. How much downtime can you suffer for each? And then think about, do you want to be responsible for the security, for the breach liability, for managing, monitoring, for the runbooks, or would you rather outsource that to a vendor and make those decisions per application? So that's really all I had for us today. Gerard, did you have any questions?
Yes, thank you, Siggy. So how do you have confidence, that your DR strategy is up to the task or set up properly?
Well, that's a tough question, right? It's very difficult to answer it with metrics. We could talk about, are your RTOs in sync? Are your SLAs there? But let's think about it from a non-technical perspective for a minute. If your organization got hit with ransomware tomorrow, and let's say the ransomware wants you to send $5,000 or $10,000 to them in order to unlock your systems. If you have disaster recovery today in place and you get hit with that ransomware, what's less painful for you? If you have DR, you haven't tested it in a while and you just did it to check a box, and you'd rather pay the money than actually go down the route of using your DR, you don't have confidence in your DR system. You don't have true DR. You don't have a failover capability, and your management, your board might have a false sense of security. DR needs to be set up so it's less painful to hit the button than pay the ransom. That's the way I would really answer that question.
That's great. Thank you very much. So thank you everyone for joining our webinar. If you have any further questions for us or would like to learn more, you can reach out to us at sales@webair.com, or you can give us a call at 1-866-WebAir1. Thank you again.